Assalamualaikum warahmatullahi wabarakatuh. I am SYAZWAN bin JASMAN. Today my group member and I will present about Lab 2 session, which is construction of AC high voltage generation and measurement. First of all, I will introduce my group member Teo Yohan and Muhammad FAIRUZ bin SALLEH. So we as a junior of testing engineer in FTKEE are required to do the installation test to ensure the insulator property meets the International Electrotechnical Commission IEC standard. So for our responsibility is to do the electric strength test, or we can call it as hypo test. Therefore, the following step must be compiled, which is divided into 4 sections. So for first section is about identify a correct apparatus for hypo test, and second section is about assemble AC generation and measurement system, and third section is about fix all grounding termination point, and last for the fourth section is about neatness and clean. And all the information in this presentation session we get from the manual book of high voltage construction kit 4.0, and we are also referring the lab session video from our instructor TS Dr. Zikri Abadi Baharudin. So thank you to our instructor. So okay, for objective for this lab session is consists of 2 objectives, which are to familiar with the basic component of generating AC high voltage and construct AC generation and measurement circuit by considering frequency converter and high voltage transformer. For section 1, we need to identify which correct apparatus for hypertronic test. So we have been given a list of apparatus that we need to tick, which are used in hypertronic test. So we can see the list that we already tick, what apparatus that have been used for hypertronic test. So the apparatus is type PZT 100-0.1, where this is a test transformers 100 kV, and we use type CM for measuring capacitor, then type ES grounding switch, then EL for top electrode, then we use type V for connection rod, then K for connection cup, type FS for flow pedestal, and lastly type SEK AC for secondary part for CM AC. Next, for section 2, we need to expand the assemble AC generation and measurement system. So the figure shows the winding transformers diagram, where this diagram can be saw at the nameplate of single phase AC voltage test transformers. So at primary winding side, it consists of 2 PU, 2 PX, 1 PU and 1 PX. So for secondary winding side, it consists of T, S1 and SO. The rated voltage for single phase AC voltage test transformer is 2 times 220 volt, 440 volt, 100 kV and 220 volt. For rated power is 9 kVA continuous 1 day on, 1 day off, 10 kVA 1 hour on and 1 hour off, 4 times per day. The two figures shows the connection of frequency converter to transformers, where the difference is at the connection of primary winding side. So we can see the difference is at primary side. So the connection is start from main supply 414 volt, where it will power up frequency converter. So from frequency converter 1, from frequency converter, one cable that contain 3 wire, which are live wire, natural wire and ground wire, will go to single phase AC voltage test transformers. But the grounding wire from frequency converter will be connected with the copper braided, which the copper braided already attached to grounding of single phase AC voltage test transformers, and the copper braided is connected with lab grounding. So for the left figure, it shows the connection frequency converter to transformers, where the primary winding side is parallel connection. And for right figure, it shows the connection frequency converter to transformers, where the primary winding side is series connection. So to become an insulating transformers, the primary side should be connected in parallel, which is connected the 2 PU to 2 PX and 1 PU to 1 PX. So when this connection have been made, the primary side will also 220 volt because the connection is in parallel. So the secondary side will generate the potential difference from point T to point S1, which is equal to 220 volt also. To generate high voltage, the primary side should be connected in series, which is connected the 2 PS to 1 PU. When 2 PS and 1 PU is connected, the primary side will become 2 times 220 volt, which is also equal to 440 volt. The secondary side will generate the potential difference from point T to point SO, which is equal to 100 kV.
Thank you to SYAZWAN. My name is YONG. Now I will continue the presentation with assemble the basic component with the connection from transformer to the capacitor for the measurement. From the figure above, we can see that the connection between single phase AC voltage test transformer and measuring capacitance using a connector rod. A connecting cap is put on the top of top electrode so that the connector rod can be connected. The top electrode is put at the top of the measuring capacitance to avoid the corona effect. At the bottom of measuring capacitance, a 4 pedestal is used for the grounding system using a copper braided which are connected to the grounding lab. A switching grounding also used by touching the top electrode to discharge for the equipment after the testing. At the end of measuring capacitance, a male-to-male coaxial cable with 50 ohm is used to connect the secondary capacitance to microfarad. And the output of the secondary capacitance will connect to the frequency converter using another coaxial cable. The grounding of the secondary capacitance is connected to the floor pedestal using a grounding cable with banana jack. Another grounding is at the banana to female connector at the end of the secondary capacitance. The measuring capacitance and secondary capacitance is connected in series. Voltage is divided up in a capacitive DC voltage divider according to the formula V equal to QC. Therefore, the voltage is inversely proportional to the capacitance value of the capacitor. So, the capacitor with the smaller capacitance will have the greater voltage, and conversely, the capacitor with the greater capacitance will have the smaller voltage. Next, I will show the capacitive divider for the measurement by considering high voltage level to a low voltage level. From the diagram above, we can see that the voltage supply is 220 volt, which is supplied from the transformer using parallel connection in primary side. The reactance of each capacitance can be calculated using the formula 1/2 pi Fc. Since the capacitor is connected in series, we can find the voltage in each capacitor using the voltage divider. For the result, we see that the output voltage for the C1 is 219.99 volts, while C2 is 0.01 volt. How about 100 kV from transformer? If series connection in primary side of transformer, the output of the transformer will generate 100 kV. By using the formula just now, we see that the voltage output for C1 is 99,994.87 volt, while C2 is 5.13 volt. For the specification of measuring capacitance and secondary capacitance, the maximum voltage is 100 kV, while the secondary capacitance is only 7 volt RMS. All the capacitor and the measuring prod are still in safety condition when using 100 kV and 220 volt. Next, I will explain the symmetric structure of secondary capacitor. This is a simple diagram for the secondary capacitor. At both ends of the secondary capacitor, they have 3 banana ports. The middle port is used for the current flow from the measuring capacitance and flow to the frequency converter. The other 2 ports is used for the grounding. The banana with female connector is connected at the both ends of the secondary capacitance, so that the male-to-male coaxial cable can be connected from measuring capacitance and to the frequency converter. This is the symmetric circuit diagram of the circuit board capacitor. All the 20 capacitor with 0.1 microfarad is connected parallel with the varistor. Why we say that the capacitor is connected in parallel? Because for the C total, all the capacitance has been added up, and finally the answer is 2 microfarad, which is same as the rated capacitance of the equipment. That's all for my presentation. I will pass to my another member, FAIRUZ.
Thank you, Tio. Hi, Assalamualaikum. My name is FAIRUZ bin SALLEH. Now I would like to continue the presentation with the question in the section 3. In this section 3, I would like to explain the connection between the 2 capacitor of divider using coaxial cable, and the other end of the secondary capacitor is connected to the termination point of frequency converter. The connection between the single phase AC voltage test transformer and the measuring capacitance is using by the connector rod. In the top of the measuring capacitance, there is the connecting cup that holds the connector rod. Below the connecting cup, there is the top electrode. The function of the top electrode is to avoid the corona effect. The top electrode is connected to the switching grounding. The connection between the secondary capacitance and the measuring capacitance is using the coaxial cable. The type of coaxial cable is the RG58. The coaxial cable is male-to-male coaxial cable 50 ohm. In the secondary capacitor, there is the grounding cable that is connected to the floor pedestal using by the banana jack cable. The connection between the secondary capacitance to the frequency converter is using the coaxial cable, male-to-male coaxial cable 50 ohm RG58. The coaxial cable is connected to the point VM1 female port. In the port, there are 6 ports. VM1 and VM2 is for the AC measurement. VM3, VM4, VM5 and VM6 for DC measurement. For the VM1 and VM2, the max voltage is 7 volt RMS. The switching grounding is connected to the point in the frequency converter is the grounding switch. All the equipment body need to be grounded using the copper braided that is connected to the grounding on the left. Now, I would like to continue my presentation with the explanation of the coaxial cable RG58. RG58 is a coaxial cable that is used for wiring purpose. A coaxial cable in general consists of an inner conductor that is surrounded by a spacer. The RG58 cable frequently acts as a generic carrier of power signal. Below is the specification of the RG58. The type of coaxial cable is the RG58C. The impedance of the coaxial cable is 50 ohm. The electric is solid polyethylene. Time delay is the 1.54 nanosecond per feet. Propagation velocity is 65.9%. Capacitance is 30.8 picofarad per foot. Outside dimension is 0.195 inch. The frequency is 14. Maximum voltage PRMS 1900. The shield is the braided. The other side is the drawing diagram of the RG58. We can see this the cable stripping of the RG58. There has inner conductor, insulation, outer conductor and sets. Next, I would like to explain the way to ensure the neatness and clean testing layout. First, proper cable management with not crossover with other cable. This will help to avoid the danger that can happen in the lab. Second, rearrange the equipment with the most suitable place to avoid the cable crossover. Third, keep equipment and tools that does not related to the lab session. This will help you to make your surrounding testing area is in the clean condition. And fourth, keep all the equipment to their original place after done the lab session. That's all for our lab presentation for this lab session. Thank you for watching.